الرحمن الرحيم. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات لغات، السلام عليكم ورحمة الله وبركاته. اليوم سنتناول مراجعة على الوحدة الثانية في مادة الاستاتيكا، وهي مراجعة على العزوم. ونظرا لأن الوحدة الثانية مهمة جدا جدا، العزوم على 2 dimensions and 3 dimensions. Welcome my dear student in our math program for second 3. Today we are taking revision about the moment about 3 dimensions. My dear student, we know that the moment has 2 directions. Positive in anti-clockwise, negative in clockwise. And we know that the moment equals R cross F. R is called in 2 dimensions position vector of this point, which the force act on it. But the force, this component of the force. And we know that we use determinant to calculate the moment by using determinant 3 IJK, first row, second row component of the R, third row component of the force F. My dear student, look at the first example. If the force F in same plane as a parallelogram ABCD and the moment about A negative 18 units, moment about B equal moment about D equals 32, then moment about C equal what? Choose the correct answer. 81, 82, 70, or 80. My dear student, we know that if the moment A equal moment B, then the line of the force act at midpoint of AB. Look at, we have ABCD as a parallelogram. We know moment about B equal moment about D, then we know that the line of the force parallel to BD. Look at moment from given about B equal 32. What is the moment from the figure about B? The force multiply the distance H1. Look at F times H1 equals 32. Moment about A from given equals 18. Then moment about A equals F times H2 equals 18 from the given. Remember, moment about C equals what? F1 plus F2 plus F1 times F, or FH1 plus FH1 plus FH2 equals 32 plus 32 plus 18 equals 82. This example very important. We have moment about A, moment about B, and to calculate moment about C. Moment about C equals F times the distance from C, H1 plus H2 plus H1, or 2H1 plus H2. From the given to calculate the moment about C, 32 plus 32 plus 18 equals 82. F1, F2, F3 are 3 forces act at point 2, 3. Remember, my dear student, this example is important. We have 3 forces act at the point 2, 3. F1 equals 2I plus 4J, F2 equals I minus 2J, F3 equals negative 3I plus 4J. Then the moments sum or sum of the moment of these forces about the origin equals 6k, 12k, negative 6k, negative 12k. Choose the correct answer. My dear student, we know that the moment about A equals R cross F, or we use the vector product in 2 dimensions. Look at the first sum of the forces. We have 3 forces equals 0, 6. Moment about O equals the force point 2, 3 or R cross F cross 0, 6. This moment 2, 3 equals 2, 3 cross 0, 6 equal 12k. Now we are translate to another one. If the magnitude norm F equals to root 5 Newton, act along AB vector, where A equals 3, 4, point B 4, 6. Then the moment vector of the force F about the origin point is, choose the correct answer, 4k, negative 4k, negative 6 root 2k, or 6 root 2k. Choose the correct answer, my dear student. At the first, find AB vector equals B minus A. Point B, 4, 6. Point A, 3, 4. 4 minus 3, 1. 6 minus 4, 2. This is the vector AB. Then we know that the vector F equals the norm F over square root or norm AB vector AB. Therefore, we deduce that the vector F 2 root 5 over square root 1 square plus 2 square 1, 2 ordered pair. Remember, denominator square root 1 square plus 2 square equal root 5. We simplify 2 root 5 over root 5 equals 2. Therefore, 2 times 1, 2, 2 times 4, 2 times 2, 4. Then the force F, 2, 4. Moment about O equals this R cross F, R 4, 6, and F 2, 4. Then 4 times 4, 16, minus 2 times 6, 12. Answer is 4k. The moment about O equals R cross F. F unknown. From the given, we find the value of the F force 2, 4. Then we use vector product 4, 6 cross 2, 4, 4 times 4 minus 6 times 2. Answer is 4k. And the given figure, algebraic measure of moment of the force F about the point A equals what? Newton. Look at the figure. Choose the correct answer. Look the figure about point A. We have the force F 100 Newton. Act with horizontal 45 degrees. The distance AB equal half meter. BC 3 over 2 meter or 1.5. The required, what is the moment of the force F about point A? At the first, we know that the moment F equal R, moment of the force F about point A equal R cross F. In this case, my dear student, we resolve the force F about two components, horizontal, vertical. Horizontal 100 cosine 45, also vertical 100 sine 45 is the same value. Why? Because cosine 45 equals sine 45, each one equals root 2 over 2. The distance between the first 5 or 100 cosine 45, which horizontal, is what? 1 over 2 meter. Look at, my dear student, at the first force, negative 100 cosine 45 with clockwise with negative sign. Negative 100 cosine 45 multiply distance 3 over 2. But 100 sine 45 is positive, multiply 100 sine 45 multiply 1 over 2. Answer is negative 50 root 2. Now we are translate to another example. If the moment of the force F 3I plus 4J plus 12K about the origin point, then equation of the force line of the force is, choose the correct answer. Remember, if the moment of the force 3I plus 4J about the origin point is 12K, this is the value of the moment. We have force F, its component 3I plus 4J, act or about the origin point is the value of the moment 12K. Then equation of the line of the force F is 4x plus 3y equals 12, 4x minus 3y equals 12, 4x minus 3y equals 6, 4x minus 3y equals 0. Choose the correct answer. Look at, my dear student, at the first we let or suppose R equal xy, R equal xy, R cross F equals 12, 12 is the moment, R, we don't know the R position vector, cross F 3, 4 equals 12, then 4x minus 3y by using equals 12. Another example. If the force F equals 3I plus AJ plus 4K acting as a point A 1, 0, negative 1, and the moment vector of the force F about the origin, about the point A 2, negative 1, 3 is negative 4I plus minus 8J minus K. Then, number A. Remember, my dear student, we have the force F has 3 components, 3A, 4. A unknown, coefficient of J, acting at the point A 1, 0, negative 1. And the moment vector of the force F about the point A 2, negative 1, 3 is negative 4I minus AJ minus K. Then A equals, choose the correct answer, 2, negative 2, 0, negative 8. Look at the solution. R vector equals 1, 0, negative 1 minus 2, negative 1, 3 equals negative 1, 1, negative 4. This R vector. The moment about A by using determinant IJK, R vector, negative 1, 1, negative 4, component of the force F, 3A, 4 equals 4 plus 4AI plus 4, then we deduce that 4 plus 4A equal negative 4 by using 4A equals negative 8. then the value of A equals negative 2. The correct answer is negative 2. Now we are translate to another example. A, B, C, D is a rhombus. We know that rhombus is quadrilateral which all sides are equal in length. Each two opposite angles are equal in measure. Rhombus special case of parallelogram. Sum of two adjacent sides, sum of two consecutive angles equal 180. Two diagonals in a rhombus are perpendicular, not equal. ABCD is a rhombus of side length 12 cm. Measure angle A equals 60. Forces of magnitudes 11, 6, 5, 7 newtons. Act along BA vector, BC vector, DC vector, DB vector, respectively. What you mean respectively? Means 11, the force 11 act at BA. The force 6 acts at BC. The force 5 acts at DC. The force 7 at DB, respectively. What is the algebraic sum of moments of these forces? About A, about the point intersection of its diagonal. Look at ABCD is a rhombus, the green region. Its diagonal AC, BD intersect at point M. We deduce that the side length of a rhombus 12 centimeter, AB 12, AD 12, CD 12, BC 12. Remember, two diagonals bisect each other. Angle A equal 60. Then AC bisect angle A. AC perpendicular BD. Then we deduce measure DAC equal 30. Then we deduce the perpendicular MN by using opposite angle 30, half length of hypotenuse. AM equals 12 sine 60 equals 6 root 3. Sine 60 root 3 over 2 times 12, 6 root 3. Also, MN equals 3 root 3 is half MN of AM. AM, remember, equals what? Equals 6 root 3. MN, opposite angle 30, half length of AM, equals 3 root 3. This is the value of MN, also MY. Moment about A, look at the point A. We have 7, the force 7, and 6 and 5. 7 times 12 sine 60. This is the value AM, 12 sine 60, the length of AM. Minus 6 times 6 root 3 plus 5 times 6 root 3. The answer 36 root 3. Remember, when find the moment at point A, we have two directions. Opposite direction or clockwise and anti-clockwise. Clockwise, negative 6 root 6 times 6 root 3. But anti-clockwise, the force 7, the force A, the force 7, the force 5. Then we deduce that moment at A, 36 root 3. Moment about M, intersection of its diagonal. How many forces? 5, 6, 11. 5 and 11 anti-clockwise, but 6 is clockwise. Then we deduce that the moment about intersection of its diagonal 30 root 3. Remember, my dear student, this example very important. We have many informations about the moment about point A, also moment about intersection point of its diagonal M. And we know that the moment equals the force times the distance between this point and the action line of this force. When find the moment about M, we have three forces, 5, 11, and 6. 5, 11 with anti-clockwise with positive direction, but 6 rotation, its rotation clockwise with negative sign. Moment about M equals 30 root 3. My dear student, if a body of weight 4 kilogram is placed on a rough inclined plane with angle 30 degrees, then the body is about to slide. If the body is tied by string making 60 degrees with horizontal, making a body about to move up to the plane, then the tension in string, the force of friction. This required. Look at, my dear student, mu equal 1030 equal root 3 over 3. Then in vertical equation, we know that n plus t sine 30 equal 4 cosine 30. Therefore, n equals 2 root 3 minus 1 over 2t, this equation number 1. Equation 2, in horizontal, t cosine 30 equals mu n plus 4 sine 30. We know that sine 30 equal 1 over 2. This equation became root 3 over 2, t equal root 3 over 3 multiply 2 root 3 minus 1 over 2, t plus 2. Therefore, the relation between t and in this case, to find the value of t, therefore, we deduce that tension force to root 3. Also, from 1 to find the n by substitution, n equals 2 root 3 minus 1 over 2 times 2 root 3 equals root 3. This is the value of n. My dear student, now we are translate to another example. A body of weight 50 newtons is placed on a rough inclined plane and is acting on by a force B along the line of the greatest slope. Upwards, given that the body is about to move upward when the force B equals 30 Newton and is about to move downwards when the B equals 20 Newton. Find coefficient of friction between the body and plane. My dear student, look at, we have two motion, upward and downward. Upward when B equals 30 Newton, but downward when B equal 20. Look at the first, moving upward. Look at the opposite figure, mu Sn is downward. Why? Because mu Sn, static friction force, is opposite the motion. Then we have n equal 50 cosine theta. From the first equation, second equation, 50 sine theta plus mu n equals 30. This equation number 2. When the body moving downward, we know that mu Sn is upward. We have two equations. The first, mu Sn plus 20 plus B equal 20 in case moving downwards. equal 50 sine theta. Therefore, 30 minus 50 sine theta equal 50 sine theta minus 20. Therefore, we deduce that sine theta equals 1 over 2 or theta equals 30 degrees. By substitution in equation 1, to find the value of n equal 50 cosine 30, we know that cosine 30 equals root 3 over 2, 25 root 3. Also, substitution in equation 3 to find the value of mu. Mu times 25 root 3 plus 20 equal 50 times 1 over 2. Then mu, or static friction, coefficient of static friction force, equals root 3 over 50. My dear student, by the end of the lesson, we know that the moment at A, if the moment at A equals moment at B, then the line of the action of the force parallel AB. But if the moment at A equals negative moment at B, then the action line of the force bisect AB. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.